number on OSHA's hit list. Fall protection is coming up fast, but right now it is still there. So, okay, what is 70E? NFPA 70E is electrical safety in the workplace. NFPA 70 is the National Electrical Code, which tells you how to make installations, and then there are different alphabets following on particular items or systems. 70E was adopted by OSHA in 2009 as the minimum working standard. They set a general duty clause for failure to follow a nationally recognized standard. This edition is 2015, and I would recommend anybody working with electrical, they have a handbook. The code is one thing, but the handbook explains it in detail and the interpretation of it. So the objective here is providing training to ensure that all working around electrical equipment understand arc flash principles, injuries associated with the incident. NFPA 70E is the standard to assist being detected. It starts at 240 volt 3-phase or greater with one of 208 3-phase. How when they came out with the 2015 edition, they have dropped it down to 50 volts or greater that PPE must be worn. It doesn't have to be a full suit on the lower end. You will need as you open up active or energized panels. So basically, what is electricity? It's the current or power that results from the movement of electrons through a conductor, done by electromagnetic force in the generating process, and the higher the voltage, the more power is put. If we take a water analogy of electron flow, the V for voltage is like the water pump. It creates pressure. R is resistant or ohm, such as a pipe would give in water, and then the gallons per minute, or measured in amperes, it does the work. So the higher the amperes, the more dangerous it becomes. A load is created when electricity flows through a conductor. Now, 80, it requires 1-inch separation. Lower voltages can go closer. Higher voltages have to move considerably apart. Now look at electrical hazards. We have fires, shock, explosions, and burn can result in severe injury or death. These things that cause us the problems, and we're starting to see new numbers out because falling off a ladder would just call that a fall. Now it's associated with electricity. It's now being listed by the Bureau of Labor Statistics, so we're beginning to see a better on what electricity is doing. The most common is burns, and primarily in the hands where it takes place. Typically, it can penetrate very quickly. Natural skin can hold back 30 volts. Above that, it will penetrate. Now, if you have anyone that ever receives injury where there is an endpoint and an exit point, they immediately taken to the ER. No questions, no feel fine. I had an electrician do this. He took it to the finger and it came out the wrist where he was grounded out. He was touching the cabinet. Didn't want to go. That night about 2 a.m., the pain started. He was rushed to the hospital and they eventually had to amputate the hand because of the damage done without being taken care of early enough. So the skin is the largest organ in the body and protects you from everything. But if you burn off the layers of skin, any type of disease or germ, bacteria can come from the outside very quickly into the body. Versions are arc flash. They minor to very extensive. This photo is showing a staged event. We have what is known arc and spark. Arc jumps from point A to point B, basically phase to phase, phase to ground, or leg to leg. Arc is the molten material or burn material of copper and any other metal that in there, plastics, and are cast out. And this is why at 3 volts or greater arcs, hot metal will come out and can cause significant eye injuries and skin burns. Another occurs from direct short, ground to or phase to phase. The temperature can be as high as 36,000 degrees Fahrenheit in a microsecond. The level can reach up to 160 decimals, and the exit speed of the explosion can get up to 700 miles an hour. Everything depends on the current available. It's called fault coming from the grid and time of the protective device that help in event this happens. Unfortunately, many of the clearing devices take 3 cycle seconds, 60 cycles to a second, to clear. So the arc is taking place, the temperature goes higher. The highest one ever recorded was 36,000 degrees so far, and it caused significant damage in a short amount of time. Again, fault current coming in off the grid. When you start a short, they're saying your company are beginning to take more power, so we need to send more there. Now, it would be several microseconds, up to a cycle second, 2 cycle seconds, 3 cycle seconds. Then it realizes it's too much, and the safety device kicks in and trips it out. A day, we have 5 to 10 arc flash explosions each day, 24/7. There are reasons for this. Lack of maintenance is one of the largest ones. And OSHA is adopting 70E and boy for minimum maintenance standards on all electrical equipment. Statistically, approximately 1,000 fatalities occur each year from electrical shock of some type. Over 30,000 non-fatal electrical shock accidents occur each year. The 4th cause of industrial fatalities after traffic, homicide, and construction. And this last one really bothers me. Over 2,000 admitted to burn centers due to arc flash incidences annually. This is a real problem, and OSHA is doing everything they can trying to get it under control again. Protection is based on 4 protect strategies. Create electrically safe work condition. Really, this is isolating what you're working on and de-energizing. Now, once you log out, you must test for it. And unfortunately, yes, you must have the appropriate PPE on at the time until you can verify the absence of voltage. Once done, PPE is no longer required. Trained, which is very important. Task is important. Selection and use of PPE, and this is where there's always an issue. Clients you go into may not have completed an arc flash risk assessment. Without that, it's very difficult to determine PPE. In code, if it cannot be determined, you have to go to a Category 4 suit, which is one of the heaviest. Safe work practices. If you notice in the photo here, this gentleman is turning off a 2,000 amp circuit breaker. Now just back to it. Using the left hand, in the event of an explosion, it will turn him away from it and pull out of the way. If he was doing right-handed, he would turn into the blast, cause significant injury. So a left-handed rule is another way of doing it. This is in a Category 1 outfit. Now, in electrical systems, electrical work permits are required. However, for troubleshooting, anything of this nature does not require a permit. Once you're on something such as tightening a lug, make a connection in an energized panel, at that point that becomes work. You must follow procedures we're going to discuss in detail because most companies forget to do this or are not aware of it. Helps that the correct steps are taken. So when you talk about your procedures, you talk about the steps being taken. From time, you need to do a periodic safety audit of your people working electrical. On electrical workers who that primary job or is very primary to whatever work they're doing, this has to be done once a year and documented. Watching them do their work, making sure it's done correctly. You can write them. Joe took care of it, everything fine, but John, he didn't. Needs a little more refresher training. Now, on the right. Now here is in water. It's aluminum. He's using a power drill. He's barefoot, way in, so he's waist wet, leaning against the aluminum. If anything goes wrong, he's a perfect ground. The pool, because of the piping, piping is metal and it goes underground, and this does set a perfect ground. But it's safety oriented because he has his safety goggles on. Activities such as installation, inspection, operation, and maintenance are all part of this. Maintenance is a critical factor of electrical safety. If devices are not being maintained properly, they will not clear in the appropriate times. Now, definition, just so we understanding arc rating. This is a value attributed to materials that describe their performance to exposure to an electrical arc discharge. It's also called incident energy and is measured in calories per square centimeter. It is a heat sensing one. This using the metric system. The U.S. system, the BU. That's I'm going to go through that in a moment. Labeling on the equipment that is required. Arc flash and hazard. You have the boundary mentioned. It's 24 inches. Once further than 24 inches, you must be fully protected. Very large numbers. It's 3 calories per square centimeter at inches from the source. Therefore, category 1 PPE level is recognized. Then we down to the voltage. In this case, it's 480 volt AC. When the current is removed, now we have to establish an appropriate 42-inch limited approach boundary. This is a physical boundary and must be put up time you open a panel. Once the panel has been de-energized and the absence of voltage, that can come down. One is what is called the restricted approach boundary. Installation, primarily it is up to 480. It gets larger up, but sometimes the calculation due to a pre-installation, this could go up to 24 inches. All that's telling you, the restricted approach boundary, only a qualified electrical worker go in there. Unqualified are not permitted. Now, this shows a prohibited approach. That has now been removed. It was 1 inch. You have all your gear on once you get within the arc flash boundary. So, remove that. There are still labels showing it, and it's no longer recognized. 3 approach boundaries. The limited approach is 42 inches. The restricted approach is 12 inches for most sources. The arc flash boundary determined by calculation. All persons inside the boundary must wear PPE. Now the arc flash boundary is calculated at 60 inches, then the physical boundary of the limited approach must be extended out to the 60-inch mark. Inside that 60-inch mark can sustain a various or fatal burn. This is related on the discharge coming out of the panel. It is superheated air and material, and it rises rapidly. So the further away you get, the heat actually diminishes as it's going upward. In a cycle like this, you have your exposed energy conductor as part. Then the restricted boundary, which would be the 12-inch. The limited approach boundary, which will be 42 inches. But here the arc flash boundary is greater, therefore this boundary must now be extended to this area, then the physical barrier. Here is where they're doing a category 4, which is 40 calories. They're pulling a bucket out to do some work on it while energized. Now, condition means the load has been removed from the unit. It's important to remove the load before disconnecting a breaker, whichever way you want to look at it, because not arc rated. It has the potential of creating arc in the panel. Once the arc begins, the damage starts increasing rapidly due to the heat and can cause significant damage. I have the results of an arc flash on 480 that in less than 1 microsecond, 750,000 amps came into the building, blowing the main electrical room, blew the walls out of it. Never seen force that high before. I've seen it destroy panels, but not destroy the room. So one unit has been isolated, then disconnect. And that's when you turn it off. Disconnect is locked in the open position. This is critical. If it is not locked, it is not considered electrically safe. And paddle switches do have devices that can be put on them. Everyone out there does have a device that can be used to lock it out. Now, the qualified electrical person is who has demonstrated skills and knowledge related to the construction and operation of electrical equipment and installations and has received safety training, the key factor to apply and avoid hazards involved. I teach class to electricians, the IBEW, a number of different places. Many of them never had this training. Out of their apprenticeship, there's very little going on again. But training is important. It must be documented. It includes on-the-job training and must be documented to help verify. Now, anybody's in the state of Texas now requiring anyone working on electrical systems in the industry license. They're still in a transition period. I think it's got about a year to go. I'm not sure on that yet. I know it's been up there for almost 4 years now. But once full effect, only licensed electricians will be able to work on any energized circuits or on any panels. Safety. This is critical. The basic expectation is installed in accordance with the National Electrical Code NFPA 70. Measures instructions. This is the listing of the material. It's important that the material be used in the installation listed for what it is. Many I see people take an electrical box that is listed, a 4-way box where they can put 2 double outlets in and put an extension cord into the box, wire it in, and then they use that as a 4-way. Knock out plug in it where you can punch it out to put a connector in. not listed for that type of work. OSHA is learning this, and they're beginning to cite it. They do make a specific box that can be used. It is good for this type of use. But the fines now beginning to come in on this as they get more educated with it. And follow the mandated by the product listing. The equipment itself must be properly maintained. Nearing it brings 70E already brings in part of it, what is called 70B. It's the maintenance and care of electrical equipment. Disconnect breakers, buckets in an SEC room, usually on the 480 side, are going to be required to be tested on a periodic basis. 70B is made up of many tables telling what has to be tested at what frequency, from annual all the way up to 15 years. So it depends on the type of equipment. And this is the real catcher. Equipment doors closed and secured. Closed door, like on a 480 bucket, latching it for arc flash explosion to escape the confines of the enclosure. And arc flash beginning will be hunting for ground, and it can reach out to a person if they're grounded or to any other grounded equipment. And are done quarter turn latches or screws, but they all must be in place once you begin normal operation again. Premise, and this is extremely important, is test before you touch. Don't touch anything, don't reach into anything until you know it's energized. That must also include to understand the specific hazards associated with electrical energy. This is fairly new in the code, and OSHA wanted it put in. People understand what's going on. Where we have a community where we're bilingual, stuff like this, some of this does not translate well into other languages. There's a misunderstanding about it, and this is why it must be fully understood. And safety-related practices and procedures required as necessary to provide protection from electrical hazards associated with effective job or task assignment. Now occurs. Electricity flows to of least resistance. Sense it in the electrical field as that field is growing, such as in an arc flash. It will sense where the ground is, and it will arc to it. Conductive materials, water, chemical solutions in the human body. Now, water is non-conductive. Water out of a tap, either because it has suspended minerals in it. The body, when the body contacts an adequate ground and contacts a live electrical circuit, you become part of the circuit. By OSHA, in California, a missing ground prong on a power cord, not insulated tool, but a ground wired tool, or on the extension cord itself, is a minimum $18,000 fine. Be reversed in the outlet, causing a reverse polarity. If you're using a drill motor that has a metal housing and it requires a ground and you reverse polarity, when you plug it in correctly, the inside is energized and the outside is neutral. When you reverse polarity, the outside is energized and the inside is neutral. So if you're holding that and grab onto a water pipe that's well grounded or any grounded material, current has the potential to pass through. The effects on the human body. Less than 1 milliamp is immovable. 1 milliamp is the threshold where you begin to feel it, like that raising on your arms or the back of your neck, things like that. It's an electrical field commencing. At 10 milliamps, the no let go threshold. This means you cannot release your grip. The reason for this being that the 30 milliamps gets into the nerves and overpowers the brain and causes the muscles to contract. So if you go into a panel open-handed and grab hold of something and you take a shock, your end will close down on that and keep you on the circuit. 95 milliamps isolation threshold for 0.5% of the population, and at 250 milliamps, 9.5%. What this means is interrupts the heart brain. Brain is connected by an electrical impulse by nerves to the heart. When you current into the body that crosses over the heart, it causes a fibrillation where the heart just throbs but does not beat. We've all heard of defibrillators. This is what it's doing. It shoots the heart at 200 milliamps on a automatic external defibrillator that people, regular people can be trained on, to the paramedics who use 400 milliamps. This is the heart throbbing to stop for a fraction of a second and gives the brain an opportunity to take over and begin normal beat again. If the electrical damage is in the heart, then defibrillation will not help too much. At 4 milliamps, paralysis, where the heart seizes up completely. Is tissue burning, and above 20 amps, permanent internal organ damage begins. Irreversible. It means it's fried. It's over. Now, the shock depends primarily on the path of the current into the body. If it's in on the left side and exits down the left side, as this diagram is illustrating, across the heart potential. If it's the potential of stopping it, it's the same thing with lungs. Now, if it comes across this way from left, sorry about that, left over to right, the chopping the heart is there, but it's minimal, but it's against the lungs. And coming left down to right foot, the potential is there. It goes right and straight across and back up, it lowers the potential. Now, if the right is engaged, and the right side is going to miss the heart, and it's not likely to affect it, but it can affect breathing. So the amount of current flowing through the body in amperage is what is causing the issue. Grab hold of a 1,000-volt line as long as it's less than 1 milliamp, and I will never feel it. But it may stand on end. I think you've seen some demonstrations at county fairs or science fairs, something like that. Duration of time, current through the body. The longer it's on, the more being done. Now, voltage does not mean low hazard. Now, you must understand in the code what low voltage means. In 70, the National Electrical Code, low voltage is anything below 1,000 volts. And 1,001 volt or 1,001 volt or greater is considered high voltage. The National Electrical Code is now bringing in medium voltage, which is approximately 1,001 to 4,800, and then above 4,800 becomes high voltage. Now, 30 volts can enter the body. It may be a little less than 30 volts. In amperage circuit, there's damage, but I've seen pilot circuits that are 30 to 35 amps, volts running at 40 to 50 amps, which is a killer. It is permissible to work live below 50 volts as long as the amperage is low. So operation by code is in conditions. The unit is properly installed. It means to the manufacturer spec to the EC. Electrician out here in California who installed a 4,800 amp line using the 3 conductors and the conduit as the neutral. been outlawed for over 20 years now, and having trouble with the operation because the ground was not adequate to be as a neutral. And the person he'd been doing electrical work for over 35 years and had not gone back to any training. So this became an issue. Are to be closed and secured. It was added, all equipment covers are in place and secured. If cover on a breaker panel has 6 screw openings, 6 screws must be used to put it back together. This ensures the panel will hold up in any arc flash event. There's no evidence of impending failure. What's that? Impending failure would be discoloration, heat, insulation cracking from the heat. It's easily seen in many incidents, and I'll show you one here shortly. But then smoke is one of the most obvious, and if it's already caught fire, I think you're very aware that the failure is in progress. When it exceeds 40 calories per square centimeter, work not to be performed until isolated period. This is a serious issue. Now, there is some suits coming into the United States that are 150 calorie rated. The problem is when they're being tested, not holding up. Now, prove it all the time, so these are ongoing to make sure they can hold out whatever they're saying they can hold out. The unfortunate part is if you take a 140 calorie per square centimeter blast in 150 calorie suit, it's possible to roast you inside the suit without ever being severely burned by the blast itself. It just heats up. It's like a potato in tin and putting it in the oven. So this is very misconstrued at times. Is they required to raise 1 gram of water 1 degree Celsius. It's a heat measurement. More fuss is BTU, the heat required to raise 1 pound of water 1 degree Fahrenheit. Use calories because this is an international code. Graph, this is a dummy. He's exposed to about 35 calories per square centimeter. I'm sorry, I keep hitting a wrong button there. This was a test that lasted just a little less than 3 cycle seconds using ordinary clothing, and look what happened. The field is an ordinary plastic grinding shield some people have been using in place of an arc-rated shield, and this ignited immediately. And in an explosion, it can actually ignite, melt, and then go push to the face, which is cooler, and then solidifies on the surface of skin. Combustible clothing. Basically, this clothing is a polyester material, and it has an ignition temperature of about 580 degrees. You can see a silhouette in the background of a carry force suit, and that would have prevented this burn. Energized electrical work permit. When wired. When energized work is performed, an energized electrical work permit is required under the following conditions. When work is performed within the restricted approach boundary, that's the 12-inch boundary. When he interacts with equipment, when conductors, circuit parts are not exposed, but an increased likelihood of injury from an exposure to an arc flash exists. So if you've owned the panel and you're back away from it, it's a PPE if you're the arc flash boundary. Permit basically is the description of circuit in equipment. What are you working on? What is treated in the circuit? The volts, the amperage, AC, DC. all kinds of things. I run in frequently. I do inspections and do work on airports. There's 9,000 volt D to power the runway lights. So it's knowing your system and understanding it. Also lists the justification why work must be performed energized. In no other way, it's infeasible to do it energized, then it'd be noted. Safe work practices to be used, the left-handed rule, shielding if necessary, and we'll show you a photo of that shortly. And different methods. Then results of the shock hazard analysis. This is where you look at the voltage the employees will be exposed to. The addition, and be on all equipment now, but I still find quite a bit haven't complete yet, the limited approach boundary, restricted approach boundary. Now, I still put the prohibited approach boundary in here because it is othered a little bit from previous, so you see that. The approach boundary is just part of the restricted. This one thing just means you have full protection on before you get that close. Now, and other PPE to safely perform the work. Be approved by authorizing or responsible management, a safety officer, or owner of the business, whatever it is. Somebody in management must sign off on it. After crew sets it up, the supervisor signs off, then somebody from management. Exempt to the work, not required if a qualified person is provided with and uses appropriate safe work practices and PPE. On following: troubleshooting, voltage measuring, photography or infrared photography, and visual inspection. The restricted boundary is not crossed, does not require the housekeeping and miscellaneous non-electrical task if the restricted approach boundary is not crossed. Only a qualified electrical worker may cross the restricted boundary. In this diagram, you see the source. The restricted boundary comes out 12 inches. Then from there, the next one is the limited approach boundary, comes out to 42 inches. Then the arc flash boundary that comes out here, this is 60. Now the limited approach boundary must be brought out to this level. Anytime you enter this boundary, you must be fully protected. No skin is permitted. You keep the limited approach out here, so anyone observing from a distance, they're outside the subject of burn area. The assessment shall be performed and shall determine if an arc flash exists. Flash exists at 240 volts or greater three-phase or 208 volt three-phase with a low impedance transformer of 125 kVA or greater. It's like a 480 can. Now, below that, you will still get the arc flash, but it usually clears very quickly, but can spit out some hot metal, and that's the reason for the PE. Appropriate safety-related work practices, shielding, barriers, anything to protect the employee. The flash boundary. How is it? I'm working with a company right now where the arc flash boundary would 38,000 calories, and they have protection to 40, and the arc flash boundary was 9,160 inches. That'd be quite a bit of a problem, and done by not following installation requirements. The E to be used within the arc flash boundary. This will be category 1 through 4. Up when a major modification or renovation takes place, but not to exceed 5-year intervals. The being here, if you're in a plant that's isolated out in a industrial park, and that's the only plant out there, the grid is lower in capacity. But as more factories are built into that grid, it starts changing. more amperage is being supplied into that area, and that be taken into consideration. Fault current coming off the grid must be known to make the arc flash calculation inside the property. Takes into consideration the design of the overcurrent device and its opening time. Includes condition of maintenance now. This is an add-on. If you maintain the equipment, it will not protect us. With incident energy equals 1.2. This is usually measured at 18 inches from the source. Arc protection boundary triggers PPE requirements to protect the worker. And hard, closer, then arc flash boundary must be completely protected from thermal injury. Improper or inadequate maintenance can result in increased opening times of the device, increasing the incident energy in the heat development. Where it is not properly installed or maintained, piece selection is based on incident energy analysis, or PPE category method may not provide adequate protection from an arc flash hazard. Now, parameters are out there for assessment. The fault current, as I said before, this is coming from the power company. What is it where it enters the property line? From go on. Now, the duration of the arcing fault. If the arc is in the main and is controlled by the breaker on the pole or by computer from the power company, it can anywhere from 2 or 3 cycle seconds up to 6 to 10 full seconds, which can be a tremendous burn time. Distance between the worker and the arcing fault. The energy level lowers quickly. The fault current depends on clearing time of the current device and the amount of current in the fault circuit. Like to occur inside an enclosure from the switch contact opening and closing. When contactor, this would be control voltage. 120, that's working relays for the higher voltage. Then when a door or cover is removed or installed, fall is beginning. And microscopic at the time, and you open a door or slam it shut, it can initiate the arc to begin. Once arc begins, the fault current begins feeding. As ice clears, this will keep increasing. Time it can be held within the panel or cabinet. Break out depending on the current coming in and the clearing time from the source. Nominal system voltage, arc flash boundary, at one of the following available incident energy. Remember, incident energy is in calories per square centimeter, corresponding with working distance. The arc flash PPE category for the equipment, but not both. Marketing of clothing. Now we get into a little hassle with companies. Unfortunately, when the code first came out in 2009, was adopted, they called it fire-resistant clothing. Now they call it arc-rated clothing because fire-resistant was misconstrued. Resistant clothing may not be arc-rated, but arc-rated is definitely flame-resistant. So you've got the clothing for the particular rating in calories. It'll give you a maximum, what it might be. Specific level of PPE must understand and be able to read labels. Here, the label on the left is no marked with danger. No PPE exists. This is with 117 calories, which means no way you can be protected. Over here is a warning. We're at 18.5 calories, which is a category 3, which we'll be discussing shortly. 18 inches working from that. These labels are supposed to be on all panels where it can be opened and where a termination exists. Not a box, but in a termination panel. People in general provided must be designated for the electrical hazard, must be constructed for the specific part of the body to be protected. Workers will use the PPE that is provided. So, employer must provide and the employee must wear. Equipment shall be maintained in a safe and reliable. Take care of your PPE so it'll take care of you. If you get oil on it, it becomes an igniting source, and an arc flash event can start to burn. All protective equipment PPE must be inspected prior to use. Must be prevented against dust, moisture, deteriorating agents, solvents. Any of this will the arc rating value. Inside flash boundaries and where all parts of the body inside the arc flash boundary shall be protected. I'm repeating this for a reason, to understand there can be no bare skin. Now we go into a category 1. This is approximately 1.2 calories to 4 calories. The clothing will be arc rated. Long sleeve shirts and pants or coveralls. A shield or a hood. Now if you're working outside, jacket, parka, rain gear, must be arc rated. Then PE, go a hard hat, which will hold the face shield. Now underneath the face shield, you must wear safety glasses or goggles. Hearing protection must canal inserts. Heavy-duty leather gloves and leather footwear. As you can see in both photos, this is what a category 1 would be. The clothing is arc rated. Notice the gloves cup over so an explosion cannot go up the inside of the sleeve in working condition. And notice it has a chin or guard on here so an explosion will not press the plastic against your face. It will not melt, it will not burn. It may up and become brittle, but it will hold for the ended use. Move to a category 2. This is 4 to 8 calories per square centimeter. This requires arc-rated clothing at long sleeve shirt and pants or flash coverall, suit hood, or face shield. But now we bring in the balaclava, and I'll show what that is shortly. And a PPE now holds that hard hat, safety glasses or goggles, hearing protection, ear canal inserts, heavy-duty leather shoes, and leather footwear. Now, with balaclava, notice he's got coveralls on, but see the head covering? This is called Nomex. This is a protecting. Even though there's bare skin here, this shield is considered the barrier for it. When category 3, this is 8 to 25 calories per square centimeter. Now you need a long sleeve shirt, pants, coveralls, flash suit, and pants, hood, and gloves. We're layering. Glasses, hearing, and the gloves must be rated for going above 8 calories. Category 3 suit. Usually they're color-coded. Blue is a category 3, green, gray, or green-gray become category 4. Category 4 is 25 to 40 calories. Arc rating, long sleeve shirt and pants or arc coveralls. Suit, hood, jacket, and pants. The reason they have lowered the lighting is they've increased the thickness of the excuse me the thickness of the category 4 suit. It's the same as the others. This is getting into much higher voltage. These are category 4s, what they're working on. If you're working on something that has points in it, you can attach isolated blankets in to do the work and what you need, because the other has to be open. In the electrical explosion, it will push this outward, but it's protecting you from making contact with the arc itself as it forms. And it's to reduce shock potential burns, other electrical-related injuries inside the approach boundary. Used in conjunction with the safety signs to limit employees. This is where the limited approach boundary is mandatory to be put up if you open a panel that have live parts. Now, if you have isolated a 480 and has control voltage of 120 single phase inside the panel that is not isolated, that is considered live or work, energized work, whatever you want to call it. Is critical and is defined as preserving or restoring the condition of electrical equipment and installation, parts of either, safe for employees working on or near, repair or replacement of individual parts without requiring modification or placement of other portions of parts in safe condition. So what it is, we've got to make sure everything we're putting in is for it. If something goes wrong and you change a breaker, it should be of the manufacturer recommended breaker used in that particular situation. Breakers. When you look at a breaker that does not operate correctly, lack of maintenance or damage, it increases energy time. Now look at the situation. Circuit trip to 5 cycle seconds at 6.44 calories. This is a category 2. Now, damaged increased to 30 cycle seconds. We're less than half second difference, and look at the burn difference. 8.64. Category 4. I'm wearing a category 2 and I'm exposed to category 4. Survival is questionable. It'd be fatal or severe burns. Now, these are the same units when we look at it. Here, there's no erosion or what we call oxidation on the screws or on the surface, but look at the discoloration here. Now, in infrared photography or thermography, in more clear shows the higher the temperature, reaching about 250 degrees centigrade. What's showing us is there's a bad clip. Heat is being transferred into the connection. You see here that is also a violation. You have 2 cartridge fuses, one of a dissimilar type from different manufacturer. This is strictly prohibited. All fuses in a 3-phase must be of the same manufacturer. The clear time can be several cycles different. So these 2 might clear, and this one might be leaning a little bit so it stays energized and the arc is going. A person shall meet qualified person requirements and the standard, shall be trained in, familiar with, specific maintenance and testing requirement. We have this knowledge. If it's training, we have to document it to ensure and classify your electrical workers what they can work on, what they not work on, so they don't make any mistakes. Electrical equipment should be maintained in accordance with manufacturer's instructions. Many times what I find is the equipment comes on site, instead of taking directions out of the box, they throw the box away with the directions in it and then try to install it the way they've done it all along. There are changes in equipment and procedures. Now, the owner or owner's designated rep shall be responsible for maintenance of the electrical equipment, and this is where they bring in 70B. It's recommended practices. Maintenance. All devices shall be maintained in accordance with the manufacturer's instructions. Maintenance, tests, inspections shall be documented. They know that they're clearing on time. If they don't clear within a prescribed time, they have to be replaced. Now, that's much it. I throw this little one in just from 10. It's not quite going to do it, facial expressions such as that. But believe electric power on the loose, outside of the conductors, can be a deadly event at any point along the way. Now, I know we've covered a lot of material, and this is very light. I teach a 70E course. It's a minimum of 8 hours. We start pressing getting into gear, we go to 16 hours, depending on what the client wants. To let you know, this training is required. It must be refreshed every 3 years. Reason 70E updates every 3 years. We're in the 2015 edition right now. The 2018 is coming out, and I'm already getting blurbs from the committee. There are some significant changes coming. List, but I'm not entering that yet because it hasn't been finalized. So looking at that concludes the class for today. Now stay online and we'll gladly answer any questions that people have. And I'll stay here until online until I answer what you need to know.
Hi guys. I'm looking for a question because Frank had said, Frank and Jay sent a question saying he was looking forward to hearing how people work in this practically. I'm sure there's some questions on that. Do you guys have any feedback? I want to hear what others are doing. How are they implementing and adhering to the guidelines in a practical manner?
Instructor's point of view, practical means where equipment in the work or substituting by having an electrician do the work and your people doing it. It's called substitution. It takes the liability off of you. But at the time you are working above people's PE is required, and boundary approach must be physically established. The stanchions which on it do not enter. It's to establish the boundary. Any thoughts?
All right. Well, thanks for attending, everybody, and a big thanks to Greg. We really appreciate all of your help. And I do have a question that I see typed in. What impact will the new laws in Texas have on HVAC service?
If you're going in there, on this account coming in, you're going to need a license if you open an electrical panel. But still not in place, and there may be some changes to it. But right now, we're holding until they adopt the final rule. Everybody, and many companies there are already in transition. Some not, some have never even heard of it, but it's coming. It's overruled in Austin. I just don't know right now. I do know I work with several companies there, several large plants, and they are definitely transferring and documenting the hours. It takes 8,000 hours to be licensed. So they're given the time frame to be documenting the working time so they can take the apprenticeship program and be licensed with the experience they are having there. This is in transition. Does that question for them?
It says normative. It answers the question.
And
talk if you have any questions or thoughts. Please feel free.
Okay.
Good. Again, thanks everybody for being on, and I'll send you all a recording of the webinar as soon as I get the link. And Greg, thank you for everything and for being our safety expert that we can talk to.
Okay, and Jan, if they come up with questions later, email you and you can send it on to me and I'll respond.
Perfect. Okay, if any questions, let me know and we will get them over to Greg.
Thank you. Bye.